Okay, Aryan, can you hear me? Aryan, can you hear me? Okay, good. Aryan, on Sunday, do you feel do you experience the bad audio, like you cannot hear me, things like that?
No.
Okay, understand. Right. So let's be aware again for today. Yeah, we're going to use the same Jamboard. Yeah.
We're
So
doing electrolysis, right?
Sorry, you're saying, Aryan? You're saying?
We're doing electrolysis, right?
We'll just continue slowly like when we have time, right? But if you have a homework question or something you want to ask, we ask first. Do you have?
No.
All right. Okay. Then we'll wait for Mike for electrolysis. Okay. Right. Please do something else first while waiting. If you already have the dates and the full topics, yeah, for the midyear. Sorry. Sorry. You were saying that you don't have a midyear. Am I correct?
Yeah.
You're saying that you have a normal, just an exam. So it will still have topics and you will still have dates, correct?
Yeah.
Then when you have them available, please send it to me. Yeah. Aryan, we're gonna wait for another 2 minutes and then we're gonna start and not wait for Mike. Yeah.
Yeah.
Do prepare your video though. We still need your video and still refer to the Jamboard.
Two branches.
Mike, good. Can you hear me, Mike? All right. Okay, Mike. Do you have any homework questions? All right. If your math and chem is clear, then we'll just continue with electrolysis lah. Okay. All right. Okay. Okay. Mike, again, waiting for your video. We need the video, and I would like to start as soon as possible. Okay, Noah, can you hear me loud, clear?
Yeah.
Okay. Any homework questions for today?
No. Bye.
All right. Okay. So same thing. We're going to do the mid-year preparation, and you have done some, right? So you were trying to continue with the differentiation question, right? I gave you some hints. Did you manage to do it after Sunday? Noah?
Yeah.
Did you manage to continue your the questions that you chose? Right. Do you have a problem with them? Do you want to ask them?
No. Okay.
Sorry. I cannot hear everybody very well today. Yeah. Noah, again, just checking. Is my voice clear from your side?
Yeah.
Okay. Try speaking a bit, Noah.
Okay.
Try saying like a point P moves along the curve.
Point P moves along the curve. It is off.
It feels a bit like the audio is not very clear today. I'm not sure why. I think it's your audio. I'm not sure. Yeah. So if I keep asking you what's going on, then that must be the reason why. Okay. Right. So again, Noah, do you want to continue with the question? Do you want to ask them? Because I cannot hear your answer just now.
Oh, no.
Okay, right. Then have you finished because you chose 3 questions, right? The first one you're done, the differentiation one you're finally done, is it? Again, I cannot hear you. The differentiation one you're done. Okay, then the CG one, are you done?
Not done.
Oh, okay, then we are moving, we are trying to do the CG lah. And are we expecting your CG to be rusty?
Yeah.
Okay, then I will still want to try that with you. And then after I explain to Aryan and Mike, we'll just take turn explaining to you lah. Okay, right? Okay. So I'll be following you using your video. Now, Aryan and Mike, we're continuing with the electrolysis. Now, Mike, tell me where your electrolysis are right now in school. Mike, you're muted.
My electrolysis. How am I supposed to see where I'm at?
Since the last time we met, right? You say that you were at electroplating lah, or something like that. You were there like in school, right? Did you advance further than that?
A bit, I think.
And that bit is what?
It's like, like the oxidizing thing.
The oxidizing thing. Okay, then have you gotten into cell, what they call cell in chemistry? It's not biology cell, it's chemistry cell.
What
yes,
they call cell?
In chemistry. Okay.
I don't think so.
Okay,
apparently we're going to cracking soon.
You're going to what? Sorry?
Cracking.
I cannot hear you. Sorry.
Cracking.
For some reason, you're going to OChem. For some reason.
Yeah.
What's going on here? The electrolysis chapter is not supposed to stop. Oh, But the cracking, you wouldn't have much problem lah, because that's just what we already discussed in our holiday tuition, right? So Michael, setting the expectation, your chemistry will start to feel more sensible or easier to understand, but because we are prepared for it, right? That's the expectation. If things doesn't make sense, despite our preparation, we should quickly fix it. But I think we're quite prepared for your chem. Okay. So like starting for next week, I will mix in some OChem question for you already right, as a preparation for me. Okay. So Michael and Aryan, I'm going to make assumption that the second part of electrolysis will be in. Even though Mike, you're saying that they are not going to discuss them. There is a second part of electrolysis and it feels different. Okay, I'm going to make the assumption that we will be learning that for O-level. Same way that I make an assumption, organic chem is included. And so it turns out that it is included. Okay, Aryan and Michael. Now let's see, we'll see in the future whether that assumption is going to be correct or not. Now, are you at the Jamboard, the same Jamboard, page 7? If you are, write your name. Again, I'm waiting for your name in the Jamboard. Okay, good, Mike. Okay, good, Mark and Aryan. Okay, right. So this is the other half of electrolysis. Now I'm drawing you an electrolysis thing. I'm drawing you an electrolysis thing. I'm not giving you what the anode cathode. I'm not giving you the electrolyte. I'm not asking you the reaction. Now, you know that this is an electrolysis because of the presence of a battery. You have never had battery before in your other reactions, but electrolysis you have them. Now, somebody's background noise is too much, so I'm going to mute you first. This is the first time I'm asking you guys to mute. Yeah. Right, so okay. Now, when I ask you to unmute, please unmute. So again, this is the first time I'm asking you to do that. Normally, I would prefer you guys to be unmuted all the time, but your background noise seems to be quite loud today. So we're doing the muting, unmuting. Okay, so again, Mike and Aryan, this is the indication that this whole thing is electrolysis because we need the battery. Now, I was telling you that the other half of electrolysis is, well, the battery itself. That means we're going to look into the battery and see what's inside the battery, or rather what makes a battery. Before we continue, Noah, I'm not seeing your video. Any problem? Oh, now I'm seeing your video. Okay, good. Very nice, very nice. Okay, please continue. Now, Michael and Aryan, visually, we have a problem. For a battery, or they will call it a cell, they will never call a battery in chemistry. It's a historical thing. I think it's confusing to call it a cell, but just notice that a cell simply means a battery in chemistry, right? So inside a cell or a battery, you see something extremely similar to an electrolysis. So there is some confusion here. First thing first, you notice something like an anode and a cathode. Secondly, you will notice something like an electrolyte, the liquid stuff. There is, however, a difference. Michael, please unmute here. For an electrolysis, you need a battery. I claim that this is the guy inside the battery. What do you see here?
A voltmeter.
Okay. What does that mean? according to you? Aryan, you also think about it. Eh?
Why is the amount of the voltage of the current?
Voltage, in this case, voltage only, because voltmeter will
Yeah.
assume that you'll measure.
I know current is an ampere, but like
I'm
the
sorry.
voltage of the-
Yeah. I'm sorry. In chemistry, they just do it that way. Like it's a meter. It's a meter. So it's true that you can measure the volt or the ampere. So I like how you're saying it, Michael. It means that a battery doesn't require a battery. That doesn't make sense, right? A battery doesn't have a battery inside. In fact, a battery, which is all this thing, will contribute current or voltage to the outside world. What I'm saying is, this battery is basically connected like that, basically connected like that. This thing will provide current to this thing, even though they look almost the same. One more time, an electrolysis thing will certainly have battery, and a battery or a cell will certainly not have a battery. Instead, it will produce current. Okay, Aryan, if you were to unmute, make sense or not?
Yeah.
Any questions so far?
No.
All right. Now, Michael and Aryan, they will treat this subchapter, the electrolysis, and this subchapter as being totally separate. I've never seen them discuss in one question. I don't know why. They basically coexist together, but they discuss it as if they are totally separate things, right? In reality, obviously it's not. Every battery that you have used will be something like this, but they discuss it as if they are different or separate. Okay, so like that. Now I'm gonna discuss battery with you. It's much simpler than electrolysis. A battery is much simpler. Okay, here's metal number 1, here's metal number 2. Meaning to say, this is not gonna be your graphite, and this is definitely not gonna be your platinum. Usually not. This will intentionally be a metal, and this will intentionally be another metal. Again, just to be clear, reactive metals cannot play a part. Michael, please unmute. In a battery, you cannot use reactive metal. Any opinion why, maybe?
Is lithium not reactive?
Oh, yes, lithium is reactive. And you've just pointed out something important. Lithium is a kind of reactive. We'll just call it more reactive than magnesium, definitely. And it is extensively used in a battery, obviously, because most of our handphone batteries are lithium-ion batteries, right? So, I mean, I just contradicted myself. Yeah? In your O-level question, you will not, however, see lithium. You will not, however, see lithium, because lithium needs to exist with a very special electrolyte, number 1. Secondly, it must not be exposed to air at all. So reactive metal has 2 problems, water and air, because it can react with so many things. Basically oxygen. So yes, 2 problems, oxygen and water. And lithium-ion batteries must not be exposed to both of them. The electrolyte will be special. So I like your opinion, Mike. That's a very good point. Okay, sorry, you're saying? You're saying?
Oh, no, I wasn't saying anything.
Right. So Aryan and Michael, have you seen the video that warns you not to puncture a lithium-ion battery?
Yeah.
Okay.
No.
Okay. So
Does it like set on fire?
Yeah, it doesn't explode, to be clear, but it clearly becomes a ball of fire. Clearly, right? So I'll send you a link later. You can review it later. But that is damn dangerous, And that fire is very difficult to put out. By the way, it's very difficult because the lithium inside keeps reacting, and you cannot quench that fire. That is the real danger of a lithium-ion battery. That the fire will not die down until the lithium gone. Right? So for O-level purposes, lithium is not part of what we want to use in our battery. We'll just be using natural, simple, less reactive metal. Okay, because for the purpose of lithium is very dangerous. Now, give me an example of two metals, Aryan.
Copper,
Right, gonna put copper here, and then
iron,
iron, right? So Fe lah. And the electrolyte, I'm just gonna randomly put something first lah. Okay, just randomly first, just randomly. Since it's random, Michael, please give us a random electrolyte here.
A random electrolyte.
Which must have the positive and the negative, same thing.
MgCl.
Sure. I was hoping that you write MgCl2, your Sec2, please. Sec3, please. MgCl. So you have your Mg2 plus and your Cl minus, right? Okay, right. Now, so I'm claiming to you, Aryan and Mike, if you have iron in your house, which you have, and you have copper in your house, your wire, you put it in a solution of any salt. MgCl is actually a normal salt. MgCl is actually contained in your table salt. So if you just put water with your table salt, you will have NaCl and MgCl. And then you just connect these two metal, which is separate, right, with a wire, and then you connect it to something that needs battery power. You'll probably get some. It's a weak battery, but you will get some. It is too easy to make a battery in your house. The same thing that it is quite easy to carry out electrolysis in your house, right? With some dangers, right? But battery is even less dangerous because the product is usually electricity, not a lot of dangerous gases. So how does this work? It's very simple. Before we do that, Noah, are you stuck? Noah, are you stuck?
Yeah.
If you're stuck, that means you're really rusty, right? I'm going to help you, but don't wait for me. Instead, choose 3 more questions. I think we will run out of topics by then. Choose 3 more questions from the prelim paper.
Okay,
Put it in the jam. You're saying, sorry?
Just do a bit of homework instead.
I cannot hear you.
I'll just do a bit of homework instead while waiting.
Sure thing. No problem. Now, Michael and Aryan, our battery is done. Really, our battery is just done. I put different metal, connect it with a wire. The voltmeter represents whatever I need the battery for. And then I put some random salt here. Now, who is the more reactive metal, Aryan?
iron.
Okay, so reactivity series, right? C, H, Fe is here, right? And then Cu is here, right? So the more reactive one, Fe, correct, will jump down. This is basically sacrificial protection. Where have you heard that phrase before? Sacrificial protection, Michael?
Well, it's like can I just give an example? It's like
Yes, please. Yes,
the
please.
rudder of a ship. They have
Nice.
like humongous like blocks of zinc, so that the zinc preferably corrodes over like I don't know the iron.
The area, yeah, correct. So giving you another example, this could be Zn. Sorry. I'm not going to write Zn there. This could be Zn, correct? It could be Cu or it could be Zn. So we now have FeCu or FeZn. Okay, so Zn is here, right? Zn is here. So if you put FeCu, who's protecting who, Michael?
If you have zinc and copper, then zinc is Fe and Cu, then Fe is protecting Ca. Yeah, Fe is protecting Cu.
Fe will jump down. No? So what is the reaction of Fe? Okay, so we put Fe, and then the Fe will become Fe. In this case, we're going to assume Fe3 plus, right? Don't forget with 3 electrons. Okay, so this is like the Fe is releasing 3 electron. It's like that, but chemistry would like to write down that way. Okay, so I immediately have a question for you. Will it release the electron here, or will it release the electron here? Because it matters a lot. So that's the first question. If, Aryan, I pair Fe with Zn, who will be sacrificed, so to speak? Aryan, have you learned sacrificial protection?
Yeah.
Okay.
I think will be sacrificed.
If I am pairing Fe not with Cu, but I'm pairing Fe with Zn, do you even see this as sacrificial protection? Like, do you understand sacrificial protection? Okay, so is this kind of like sacrificial protection, or it looks so different?
I think it's quite different.
Okay, why is it similar? It's very simple, because sacrificial protection is very simple. Sacrificial protection is I have a metal I want to protect, and I am going to touch it with a metal I am sacrificing. How does Fe touch Zn? Through the wire, that's it. If you touch Fe and Zn this way, you are already performing sacrificial protection. It's just who is being protected and who is being sacrificed. That's the question. That's all. This doesn't make sense, Aryan. No? Is this okay?
Yeah.
Does it make sense or not? Right.
Yeah, it is.
All right. Then the main question remains, if I'm pairing Fe with Zn, who will protect who?
That Fe
Will protect Zn? No. Wrong. How do I know? But that is very simple. Zn is more reactive than Fe. Reactivity series. Yeah. Zn drops more than Fe. So Zn will drop.
Oh.
Is that easy, Sacrificial protection is that easy, right? It's really that easy. There isn't much. So if Fe and Cu, Fe will sacrifice itself, Cu will be protected. If Fe with Zn, then suddenly this is not what's happening. The Zn will be becoming Zn2 plus with 2 electrons. So it's releasing 2 electrons. That is what is going to happen. Do you understand, Michael and Aryan?
Yeah.
So can you just like repeat a bit of that, like again?
One more time, huh?
Yeah.
If I'm pairing Fu and Cu, no Zn, okay? No Zn, just Fe and Cu. Yeah. This will happen. The Cu will stay Cu. That's the whole point of protecting.
Yeah.
Cu will stay Cu. However, if I pair now Fe with Zn, not Cu, so there's no Cu here. There's no Cu. Then suddenly this will not happen. Fe will be protected and Zn will react, so to speak, to become Zn ion. So he's the one being sacrificed and protected. Okay?
Okay.
Right?
Yeah.
Determining who is reacting and who stays is also what is happening in a battery. So in a battery, from these two metals, one will react and one will not. And it just depends who is more reactive, who is less reactive. Just like sacrificial protection. They are extremely similar, so to speak. Okay so far, Michael and Aryan?
Yes.
Okay, so this is a simple battery. So, but same with electrolysis. Something wrong with that. Yeah. Something wrong with my drawing. Okay. So, same with electrolysis, though. Same thing with electrolysis, though. This is not the only reaction that happened. No? There is something else happening. There's something else happening. So what is happening is this. So I'm going to erase the electron. So sorry, I'm checking this first.
Hello?
Hello, yes.
Oh, I couldn't hear you for a while.
No. That wasn't your fault because I didn't
Oh.
say anything. So actually there is no audio problem. So good, yeah, good, Aryan. It's good that you're checking. It's good that you're checking. Okay, so we will call this oxidation, right?
Yeah.
So Zn becomes that because he's the more reactive guy, right? And then some other guy will be reduced. Now again, first thing first, Fe is not going to be reduced, or rather, no metal will be reduced. Do you have to memorize this? Oh, I hope you can understand. So no metal is going to reduce. Okay, so it's not Fe going to be Fe minus. Now we have other candidates beside Fe. We have, remember this aqueous, so we do have a H plus OH minus, right? So we have 4 candidates. This guy, this guy, this guy, this guy. Aryan and Michael, who will be reduced in this case?
OH minus.
Okay. All right. So being reduced means if your opinion is OH minus, then it has to be something even more minus, if that makes sense. It has to be something even more minus. Is it possible for OH minus to be even more minus?
Oh, then what about the Mg2 plus?
All right. So what you're saying is Cl minus also will not be more minus, that's what you're saying, correct or not?
Yeah.
Correct. So it's either Mg2 plus becoming more minus, or don't forget there is always H plus lah. Don't forget. Aryan and Michael, your opinion, which one? Which one? You're saying Aryan is H plus. All right. Again, Michael, I think you're muted. So why H plus? It's a good answer. Why H plus?
Because it is a lower jump
up.
than
lower jump than Mg2 plus. So good question. That's the only reason. So again, back to the reactivity series lah. Right? So this will not win also, so he will win. So how does H plus win? Hey, wait, very similar to electrolysis, right? It'll become H2, so this is 2 and 2, right? So 2H2. And then suddenly you have your reaction for the battery. Once you have the 2 reaction for the battery, you have finished analyzing the battery. Some question ends here, some question goes further, but this is always the basic step. Now, I have determined the reaction that's happening in this battery while giving the electron flow, So again, the Zn will react and the H plus will react, and voila, we have our battery. Now, at this point, so far, any question, Aryan and Michael?
In the oxidation, why is the zinc win?
Why is the zinc oxidized? Because the candidate for oxidation is, well, Fe, right? Zinc. And frankly speaking, there's this guy and this guy also. There's also OH minus and Cl minus. However, OH and minus and Cl minus will never win because they are jumping up. Okay?
Oh, yeah.
So Fe and Zn both jump down. Okay, so they're very strong candidate, but Fe will not win. Again, why? Because Zn jump down even better. So Zn will win. Again, something like sacrificial protection, something like that. Make sense?
Yeah.
Right. So there are 4 candidates, but only Zn will win clearly for reasons that I tried to explain. Any other question, Michael and Aryan?
No.
Okay. Now, we're discussing battery, right? So I want you to now do side by side, 1 electrolysis, 1 battery. The electrolysis must be the complicated one, the one with, either the anode and the cathode, the metal will react. So you do 1 electrolysis side by side with 1 battery, and you find out the 2 reactions. And then let's see whether you can get it. If you can get until that point, that's already good enough for today. Okay, Mike, I will follow you with that. Now, Noah, any question from your homework so far? When you're doing your homework, you seem extremely fast. I like it.
Homework, no question.
Okay, then shall we go back to the CG? Yeah, thank you for waiting. Right, so your CG, you're trying to do part 1 first. Okay, understand. Now, let's review our CG one more time. This is asking you to find a line, correct? A line equation. Am I correct, Noah? Right? For a line equation, what do you need? This is what I teach you. If they ask you for a line, you need this. If they ask you for a point, you need this. So what do you need for a line equation? You have two options. What are they?
Gradient.
You need a gradient. That's wrong though. You need a gradient and a what? And one more point. Okay. Or you need 2 points. Okay. Whose responsibility to give you this or that? No one. Whose responsibility? Sorry. The question maker. Good. Again, I think your audio is bad. That's why I keep asking. So let's see whether the question maker does his job. He is supposed to do that. He cannot forget to give you this. So, okay, let's see. PS. Obviously, do they give you P? I don't think so, yeah? Do they give you S? I don't think so. However, they did give you half of P, right? As you have noted, P is like X, 0. Well, they give me half, but unfortunately, I cannot do with half. I cannot do. I must have a point. I must have a point, not just half. I also have half S, still not very helpful, right? So let's see what other thing the question give me. The question give me O, totally not very helpful, right? It's just not helpful. Huh? What else does the question give you? The question give you rhombus. The question give you Q lah. I think that is all. Yeah, I think that's all. So can you see the rhombus, by the way? Can, right?
Yeah.
OP. Yeah, okay, good. So what do you know about rhombus? Do you know anything about rhombus?
The sides are the same.
They are what? Sorry, the sides are the same. Yeah, correct. The sides are the same. So this is anything else that you know?
That's all.
Sorry, you're saying?
I'm
Again,
not-
it's not clear. It's not clear. Hello? Hello, it's not clear. Hello. Yeah, you're not very clear. Yeah. Anything else that you know?
I know quite some for angles, but this is coordinate geometry. I don't know.
Okay, I like the angle thing before we continue. Aryan and Mike, why are you not doing anything? Sorry. Aryan and Mike, why are you not doing anything? Michael, unmute. What's happening? What's happening?
Yeah, wait, I'm not doing all this.
Okay, I cannot hear you. Yes, you're saying?
I'm not doing it on this.
You're not doing it on paper. Where are you doing it? It's very difficult to follow.
Oh no, it's not. Wait, hold on.
Okay, again, please do it on paper. Please do it on paper. Huh? Please do it on paper. So I can follow better. Aryan, what's going on? I cannot see anything. Yes, Mike?
You want us to redo this?
Create. No. Don't redo this. Create your own electrolysis because you have experience. Create another battery. That means another mixture of metal and everything. And then find the reaction for the electrolysis and the battery. You must make your own. Okay. Understand, Michael? Okay, give it a try. Yeah. Aryan, are you stuck?
No, not anymore.
Okay. Start with your electrolysis first, yeah? Okay, obviously you have more experience in electrolysis and it's harder anymore. So back to you, Noah. So you're saying the angles. Tell me, what do you know about angles?
The equilateral triangles. So it's 60.
How do you know that they're equilateral? Sorry. Are you sure about this? Huh? Are you sure that this triangle is equilateral? Are you sure about this?
Yeah.
How come you're sure about this? Because this is very important. How come you're sure?
Isn't all the sides the same?
No. I mean, this side and this side and this side and this side is the same. I agree. The triangle that you're referring to is this thing, like, for example, correct? This thing, or this thing, correct?
Yeah.
Correct. So this triangle, this side and this side is the same. That doesn't sound automatically equilateral to me. If
Yeah.
this side and this side is same, then they are at least isosceles. That one I can buy lah. Oh yeah, of course. If this side is isosceles. For this to be equilateral, this has to be 60 lo. Make sense? 60, 60. So can a rhombus be not 60? Let me draw you a diamond. A rhombus is just a diamond. See, I draw a diamond.
Yeah.
Does this diamond look like it's 60 degree and therefore equilateral? No, right?
No.
So it's not guaranteed that this rhombus is equilateral. They don't tell you also, unfortunately. Understand? Okay, yeah. Right. Anything else that you know about rhombus that you can probably use here? Anything else? Right. So they are supposed to find creative ways to tell you either the gradient or the 2 points, right? So we are open to this. Now, do you notice that they at least already tell you this line? Let's call this line OQ. They at least tell you what line OQ is. Make sense?
Oh.
They did, right?
Okay.
Because why? Because you have O and you have Q. Oh, then if I want to, I can find the line. If I find the line, then I can also find the gradient of the line if I want to. Right? Now, that's already my big hint for you. Is that enough hint for you to continue?
I'll see what I can do.
Okay. Okay. Right. Again, it will go back to what you know about rhombus. So if you like forget something or don't know something about the rhombus, it will of course be undoable. So let's see. Let's see. Okay, so Aryan, I want you to shift to the left and zoom out a bit because I cannot see anything. Okay, I want you to zoom out a bit. So because I cannot even see, oh, this is a battery, right? This is a battery, right? Now, where's your electrolysis? Oh dear. So let's talk about your battery first, Aryan. For oxidation, who is the candidate?
PB.
There's only one candidate for oxidation, really?
PB, OH minus and SO4 2 minus.
What about the Fe? How come you're not mentioning the Fe? How come Fe is not your candidate for oxidation?
Oh yeah, Fe is also a candidate.
Do you understand why Fe is a candidate?
Yeah, I understand. Fe is also a metal.
Correct. So a metal would be very happy to, give his electron if given the chance, right? Okay. Yeah. So my question to you is, how do you determine that PB is the winner in this case? How do you know?
SO4 2 minus and OH minus can't win.
Can't win because OH minus will jump up and if for O level, SO4 2 minus will never react. So that makes our life easier, right? Okay. So PB. Again, you're not mentioning anything about Fe, no?
And then PB has a lower jump than Fe.
It's a drop.
It's lower drop. Sorry, lower drop.
So for PB to PB plus is a lower drop So Fe is a like a bigger drop and because of that, you're saying that PB wins. Really, that doesn't make sense at all. It really doesn't make sense. It doesn't make sense. The way you say it really doesn't make sense. Think about it. Michael, your anode and your cathode reaction are totally wrong. You're not considering the candidates at all. You're doing it very poorly for an experienced person. I don't like it. I don't see you considering any candidate at all. What you do well is the electron flow. But I have been teaching you about considering the candidates. You did not do well there at all, and that's why you're wrong. Aryan, why does Fe win now, according to you? Why?
Because it has a bigger drop.
And
PV.
does that make sense, or are you
Yeah.
memorizing this?
Yeah,
It makes
I
sense.
did.
Okay.
Yeah,
Yeah, a bigger drop is easier, but a bigger jump is harder. Like don't think of bigger as harder, right? Depends on whether it's a jump or a drop, lah, correct? Okay, good. So now I think your candidate for this one is correct for oxidation. So you just have to find out the candidates for reduction and see who wins. Okay, so Michael, you are changing something here, lah, right? You're saying now for the cathode, the H plus, right? The H plus will replace from PB.
Wait.
Again, remember your sec 3, it doesn't become H, it becomes H2. If in case that's what you mean. Your reactive series is very bad. It's supposed to be C and H. At least remember that.
Yeah.
The C should be on top, the H should be on the bottom one, right? And then where is PB, right? The question is where is PB lah? The bottom H should be H plus, the bottom H should be H plus, just to remind you. Right. The bottom PB also PB2 plus lah, right? Okay. So who will win? Theoretically, who will win?
H.
Good. H plus. Yeah, but back to your sec 3 lah. There is no such thing as H. Good. Excellent. So we have a guess. So at least your cathode, I can kind of agree with that. All right. So your anode is now PB will win. Right. So candidate and win. So for Aryan, your reduction will happen on H plus, Ca2 plus lah, and H plus and Ca2 plus lah. Right. Yeah. Okay. And you obviously H plus win, right? Okay, good. Now your battery is great. You have the reduction, you have your reactions of your battery correct, right? I promise that battery is not as complicated as electrolysis, but I think I want you to compare it directly. Make another electrolysis side by side and find out their reaction. Okay?
Yeah.
Make sure that the anode cathodes are metals, so that it is more challenging. Noah, how is it so far? How is it so far?
Okay.
I cannot see, I cannot follow. Please shift to the right and to top. Okay, nice. So it looks to me that you're finding MOQ. The MOQ is minus, so I kind of like it, right? And then you're saying that MPS is the same as MOQ. You're not making any sense at all. You're saying that the gradient of this guy is the same as the gradient of that guy. How does that even make sense?
That's right, I wrote the X.
Right. So let's agree that this gradient totally is not the same as this gradient. You know what gradient means, right?
Yeah.
Right. It's not the formula, but it's just the slantedness, so it doesn't make sense. Now, here's the thing that you may don't know, maybe you don't know about rhombus. It's key in CG question. The problem is usually at the mensuration. For example, in this case, the rhombus. Do you know that their diagonals are always 90 degrees?
No.
So for now, I will tell you that first, and that will be very helpful, I believe, in what you want. Okay, that's the second hint. It's a mensuration in. So please try to use that. Aryan, I'm not seeing your. Sorry, Noah.
Sorry, Noah. After I find of OQ. Yeah, of P.
Well, at least you have a gradient, right? At least, right? At least,
Okay.
Right. So, hey, I don't have 1 point. We'll settle that problem later, right? We'll see what we can do, Aryan, I'm not seeing any electrolysis. Are you okay?
Wait, how do you draw the How do you do the electrolysis again? You
can refer to the Jamboard, right? I know this is new to you, so try to look at the previous Jamboard and see whether you remember something. Now, Michael, are you done with your electrolysis? You are sure about this one?
Yeah, I think so.
Looks good to me. You're missing the state symbol, but I'll just practice that. Now, so I don't see any battery though. I don't see any battery.
Doesn't need to be that circle thing.
Sorry, you're saying?
Doesn't need to be that circle thing.
Yeah, because a battery doesn't contain a battery, right? Don't change it. Just draw another one, Michael. Please draw another one. Don't do it that way. Just draw another one. Okay, decide what the metals are, right? Okay. Yeah, you draw that weird circle thing from physics, right? That's a galvanometer, right? So that's a good start, right? Then decide on the two metals and electrolyte. Noah, are you stuck so far?
Yeah.
All right, MPS2. So I believe the problem is that, does he give me any point here? For example, he doesn't give me any P. He doesn't give me R. He doesn't give me S. This is all half-half. Not sure whether we can use them. So here's my third hint. Actually, it does turn out that you need a lot of hints. My hint is this guy. Let's call this guy a name first, make it easy, Noah. So label this point, please.
In red.
Yeah, label it. Your name will be nice. Noah, label. Tell me your label quickly.
I labeled it.
Where in the Jamboard is it?
No.
Okay, I cannot see your label. So you have labeled it something. Good. Now, that is my third hint. Can you use that hint?
Okay.
Right. That is the hint. I think that is what you can use. So Aryan, are you still stuck with electrolysis?
Yeah.
Try drawing something first. I want you to try. Right? Draw it. And let me see. Michael, are you stuck with your battery? I cannot even see the metal of the battery yet. Maybe it's too small. What are the metals?
Fe.
And Fe and?
Fe and Mg.
Mg. I suppose it makes some sense. Okay, good. And your electrolyte thingy is?
I still haven't decided yet. USO4 is not an ionic bond.
No, it is.
Wait.
It's a salt, huh?
It is.
It is. It's Cu2 plus and SO4 2 minus. It will dissolve in.
CuSO4.
Right. I suppose for now it's fine. Yeah, for now it's fine. So our first task is always to decide. Okay, what will the reaction be like? Aryan, please start something. Aryan, why are you stuck? Sorry, there's so many examples, but why are you so doubtful? You can at least start with something, Aryan.
I'm not sure what to start with.
What do you mean? Are you looking at the Jamboard?
Yeah.
You say that you understood electrolysis, right? Which Jamboard are you looking at? Which page?
Page 7.
Page 7. You're looking at today's page, but you have page 6, page 5, page 4, page 3, page 2, page 1, all talking about electrolysis. Like we talked about electrolysis from a few days ago, correct? It's not a new thing, right? Right? Would you please look at them and please try something? Because as far as I can remember, you don't change your picture here. Do another picture next to it, side by side. Next to this picture, please. Next to your picture. Yeah, you have a lot of space on the right. So do your electrolysis there. Draw something. Yeah, and shift it so I can look at it. Oh, Noah, you actually use it well. How many hints? Remember the hints? What are they? How many hints do you see? Do you need?
3.
Okay, what are they? Because they are actually quite common in CG. It's not just this question.
OQ, the 90 degrees, and the midpoint.
Right. The 90 degree refers to the rhombus. That means it's a property of the rhombus. So it's a mensuration thing actually.
Yep.
But the OQ and the Z is usually more like a CG thingy. So I feel that this is something that you should have known. I think that's why you're rusty, I suppose. Okay, because once you know this hint, suddenly you can do it. You just need to use those things more, I suppose. Yeah, right. So now let's see whether you can do T or not. What is T? T is a midpoint of OS. Find the area of quadrilateral T, SQP. Right. Can I leave this to you? The T should be easy lah. So the area would be a shoelace lah. Right.
Yeah.
Okay. Good question. I hope you are getting the rusting, and I will see you on Thursday then. Okay.
Okay, like that.
All right. Bye bye. Aryan, please shift to the left so I can follow. Okay. Your metal is PB and Fe also. I suppose that's fine. Now, first thing first, Aryan, I don't see any electron flow. Electrolysis should always start with electron flow. Right? Why is that so? Why do we start with electron flow?
Because we know from where the electrons like entering and releasing.
Exiting. And that will affect the reaction totally. So I feel that you should not forget that. I feel that you should always do that, even at the start. Now, please write down the reactions. Who will be receiving the electron? Who will win? And who will be letting go of the electron? Now, Michael, are you stuck with your battery? Now, Michael, for the battery, the anode and cathode is not clear yet where. I haven't explained where the anode and cathode is for a battery. So don't do that. Don't do that. Don't do that.
Okay.
The first thing I discussed to you and Aryan is that which metal will react, therefore which metal will be not. So in battery, we start a bit different. Who will react and who will not? That is actually the easiest question to answer. Who?
Who will react and who will not?
In our Jamboard, who will react between the two metals?
The more reactive one.
Okay, so in your case, will it be different? Like the criteria for the winner, will it be different or will it be the same, right?
So magnesium will react.
Because magnesium is more reactive, and that's what happens in sacrificial protection of what? Correct? Sacrificial ocean also this happen. Magnesium will react and Fe will stay. Like I said, it's like very similar. So you can take confidence in writing the magnesium reaction. Right? Shift to the right, please, so I can see. Shift to the left, sorry, so I can see. Right? Don't write anode cathode, please. You do not know who is anode and who is cathode. You are totally jumping here. Just write down magnesium as reacting. What's the reaction of the magnesium? What? Aryan, what makes a cathode the cathode and what makes anode the anode?
Cathode, in the cathode there is like
the cation goes to the cathode. It's simple.
Yeah.
The cation goes to cathode. So for the anode?
Oh wait, the negative ion
goes to the anode. So who is the anode? Who is the anode?
The anode, the ion.
Why do you say this? The negative ion and anion goes to the anode. Who are the negative ions?
The OH minus and SO4 2 minus.
It goes to?
Oh, the ion.
Your arrow even says that the OH minus goes to PB. What's going on? Isn't that what you draw? The OH minus and the SO4 2 minus goes to PB because PB is connected to the positive side of the battery. Correct?
Yeah.
Then why do you say that the anode is Fe? Michael, will magnesium or any metal receive electron? Your secondary tree, please.
Magnesium will.
You're writing that as Mg plus 2 electron. And I cannot see after that. Please shift to the left. Please shift to the left. Okay. Okay, no? Okay, makes sense, huh? It should be like that, right? Should be like that. There's an issue. Okay, Aryan, come on, Aryan. Oh my, come on, Aryan. The anode is where the anion goes to. Who is the anode? Who is the anode?
The PB.
Why do you insist or look confused and think that it is Fe? What happened just now? What happened? What were you thinking?
I got a bit confused.
Anion goes to anode. Cation goes to cathode. That's how they get their name. Okay. In the anode PB, there's a competition to release its electron, correct?
Yeah.
So OH minus will win, or SO2 minus will win, or PB will win, assuming PB takes part in the competition.
Yeah.
Who will win? No. Who will win, Aryan? Who will win? Decide. Michael? After you write the magnesium reaction, that's an easy one. Are you confused? Okay. This will be accompanied by another reaction. The magnesium reaction is oxidation or reduction?
Magnesium reaction is oxidation.
Because the Mg become Mg2. Aryan, please decide. Yeah.
Yeah.
So the reduction will have who as candidates? Think in terms of candidates, please. The reduction candidates will be
2 plus H plus and Mg2 plus.
Well, I suppose, but it's quite clear that Mg2 plus will not win. So I assume that you're correct, but Mg2 plus will not win. So good. So who will win?
H plus. Oh, it's Cu2 plus.
Cu2 plus, correct?
Yeah.
Good, because Cu2 plus has a lower jump. That's good. You write down the reaction. And at the very least, this is the most basic thing about battery.
The reaction at the cathode.
No, don't say cathode anode. No, you do not know.
Fe.
You do not know who is cathode. Trust me, you do not know yet who is cathode. Not yet.
Iron reaction is Fe. Wait, yeah, Cu2 plus.
Yeah, Cu2 plus. Yeah. So add the iron, right? So, Aryan, could you please shift and let me see your reaction? Who will win? I cannot see. PB to plus, yeah, okay, fine. So PB will win, yeah? Why, Aryan? Okay, thank you, Michael. So at least that's the basic. So I take it that you haven't done this in school, correct? Haven't.
Yeah.
All right. I'll see you. We are way too late for today. I'll see you on Thursday. Right, Michael? Okay.
Yeah.
Aryan. Yes. So PB will win. Why?
Because SO4 minus like can't win.
Sure. And then OH minus?
Minus is jumping
up, right? So, but PB is
dropping.
So PB will always like this. Good. Now, so this is something that you learn from Sunday. It is wiser to do the anode first, not the cathode first. However, we have a tendency to do the cathode first. So I was kind of indirectly telling you on Sunday. Now I'm telling you directly. You must do the anode first because the anode will contribute a candidate for the cathode.
Oh.
So, but we human beings want to do cathode first. It's very common. Do you sense why? We will almost always just do cathode first.
Is it maybe because the positive?
Maybe that's the reason. Actually, I don't know why, but I see myself and a lot of people do that. It's very difficult to change after a while. That's why I'm like changing you right now. Okay, like starting next Thursday, right? Starting Thursday, Aryan, you're going to do anode first. You have to fight the tendency. You understand? We have a tendency to do that. Fight it because now you realize the PB2 plus can be a candidate for the cathode, right? Yeah. So will PB2 plus win or now which H plus win? Who will win actually?
Sorry?
Will PB2 plus win at the cathode or will the H plus win? Because we now have a new candidate.
The cathode the H plus.
Right. Luckily, PB2 plus will not win. Luckily, H plus will win. But we won't be so lucky next time. The candidate from the anode might actually win at the cathode. Understand?
Yeah.
So we're gonna fight our tendency and do anode first. This is one way. This is how electrolysis can be complicated. But remember to do that first. Any other question?
No.
What was the confusion when I asked you to do electrolysis? I thought you know this. Actually, you did reasonably well, but you get confused. What happened?
Because I thought you had to use all the reactions from.
No. Like the point of comparing them is to show that they are slightly different. In fact, they should feel different. The reactions should feel different. Understand? They actually don't feel very similar. Their logic sometimes similar, but also sometimes different. And that's why sometimes they're very confusing. Some people think they're very similar. Some people think they're very different. They're actually half-half. Right? If you can understand both, we are reasonably ready for the exam questions.
Yeah.
Okay. Any other questions?
No.
I will see you on Thursday then. Good job for today. Okay, Aryan. Bye.
Bye.